Hi, so we're going to continue on with more algebraic manipulations. So our goal is to take an equation that is not in slope-intercept form and get it into slope-intercept form. The reason why we want to do that is because once an equation is in slope-intercept form, it's very easy to see what the true slope and the true y-intercept are. Here, this is not in slope-intercept form, so it's very difficult to see just looking at it what the true slope is and what the true y-intercept is. For instance, this is not the true slope here. This is not the true y-intercept. Let's rearrange it to see what they really are. Okay, so if we have something that has a structure like this, what we want to do is at least get 2y by itself. It's not ultimately what we have to do, but it is a good start. So let's try to get 2y by itself. Right now we have this 8x hanging on to it. So let's get rid of this 8x on this side. In order to get rid of this 8x on this side, we're going to subtract 8x. But whatever we do to one side, we have to do to the other side. So we have to subtract 8x from this side as well. This cancels out, so I'm left with 2y equals 12 minus 8x. Now we're much closer. 2y is still not just y, and we need to get just y. So how do we get y completely by itself? Since 2 is being multiplied by y, we divide 2y by 2. If we divide 2y by 2, we have to divide every single term on both sides of the equation by that same number, in this case 2. So now these cancel out, and we're left with y equals 12 divided by 2 is 6, minus 8 divided by 2 is 4. So we're left with y equals 6 minus 4x. Very close to y-intercept form. There's just one more thing we need to do. We need to get this negative 4x in front of the 6, because it's y equals mx plus b form, not y equals b minus mx form. Okay, so we got to rearrange this here. Another way that we can think of this is y equals 6 plus negative 4x. Do you see 6 minus 4x and 6 plus negative 4x is the same exact thing? Now it's easier to see how we can switch them. If it's 6 plus negative 4x, we could say that it's the same thing as negative 4x plus 6. Okay? Do you see that when you are adding two things together, it doesn't matter whether you add one first and the other second, or the other second and the other first? You can switch them. So this is our completed y equals mx plus b form equation, y equals negative 4x plus 6. The reason why we can switch when you're adding, let's say that I had y equals 8 plus 4. You would say, oh, well, okay, well, y equals 12. Do you see that when two things are being added, I can switch them and it still means the same thing? What if I said y equals 4 plus 8? I just switched them, but it's still 12. So that's why when you have two things that are being added together like here, you can switch them. And now we see that the true slope is negative 4 and that the true y-intercept is 6. Very different numbers than if we were just looking at this. Let's try another one. What if we had 15x plus 5y equals 20? Not in y equals mx plus b form, not in slope-intercept form yet. We want to get at least this 5y by itself to start with. So let's take away this 15x. We subtract 15x from both sides. All right, so that's 5y equals 20 minus 15x. Now we need to get y by itself. The 5 is being multiplied against the y right here. So let's divide everything by 5. So we're left with y equals 4 minus 3x. 5 goes into 20 4 times. 5 goes into negative 15 negative 3 times. This is very close to y equals mx plus b form. We need to get this out in front. Remember, we could rewrite 4 minus 3x as being 4 plus minus 3x. And now do you see that it's easier for us to switch these because they're just two terms being added together? So you could add them the other way if you want. So it's y equals negative 3x plus 4. This is y equals mx plus b form, where the m is negative 3, the slope is negative 3, and the y-intercept is 4. Very difficult to see. If I asked you what is the slope given this equation, very difficult to see. But here, do you see that since this equation is equivalent to this equation, but this equation is in a different form, it's been algebraic manipulated into another equivalent equation, now you can see what the true slope and y-intercepts are. All right, let's do another one. What if we had, say, 6x plus 3y equals 21? 3y is what we're going to try to get to be isolated at the beginning, okay? So it'll be a good start. So let's take away the 6x from both sides. So we've got 3y equals 21 minus 6x. We want this y completely by itself now. Since it's being multiplied by 3, let's divide everything by 3. So we've got y equals 21 divided by 3 is 7, and negative 6 divided by 3 is negative 2. Now we have y equals 7 minus 2x. We're almost there. So how about 7 plus negative 2x? These two things mean the same thing. Now do you see that it's easy to switch these because they're just being added together, and you can add them together in either order? So we've got y equals negative 2x plus 7. Negative 2 is the true slope. 7 is the true y-intercept.